Good morning and welcome to part 6 now of Online Math Thinking Fundamentals, the series where we learn how to learn like a mathematician. Today's topic is change. So we're going to be doing things a little bit differently now. We finally get to change things up, and this will be the last part of this series, which means I can finally change my shirt. Anyways, here's the deal. Life, life is just rough and not fair, but life changes. Nothing stays the same, and therefore math is the same way. It is not static at all, right? So when we think about math and numbers, and we gotta say, hey, our good old buddy number 4 there, what's his deal? Well, sometimes he suddenly becomes a number 5. And sometimes he suddenly becomes a number 6. And you're like, oh shoot, what happened? Well, this was a +1, right? And then to get to 6, that was a +2, right? And then there's other scenarios where suddenly the 4 becomes an 8. And we're like, oh my gosh, what happened there? And that's a drastic change. You could think of that as, well, we've added 4, but since that 4 is the same as this 4, we're really going to say this is a times 2, right? And we start to think about these things a little bit differently, okay? Change happens. And typically, we're dealing with a change over time, right? That is the universe reality that we live in. Time keeps on ticking into the future, and things change and develop with it. So when we have a change over time, that leads us to a rate of the change. How quickly did it change, right? Because if you were to tell me that your salary has doubled since you started working with the company, that's like, wow, that's amazing. That's quite the growth there. How long have you been working with the company? I'm like, well, 40 years. Like, oh, 40 years to double your salary. Okay, that's not bad. And then you turn to the other guy, and he says, oh, I too have doubled my salary working with the company. Like, oh, how long have you been working there? 3 years. What? Right? Like the difference in the time scale, even though maybe they made the same amount started and it's now doubled, the time difference, right, tells a drastically different story. And what we're trying to do is start telling stories with our numbers. Now, when I say rate, some of you may key in and say, hey, wait a minute, I've heard that in math before. That's going to give us a slope. The slope of a graph is the rate of change over time, right? Good old rise over run. But there's a little bit more to it than that. Because when you really start getting into the higher levels of mathematical thinking and analysis, you quickly run into ideas from calculus. Calculus is quite literally defined as the study of change. So let me make another graph here that's a little bit different. Whoop. Uh-oh. What is the slope of this graph? What's its rate of change? It's not a single number. The rate of change is changing. Oh, now we got change on top of change, right? This is why it's such an important concept for you to start thinking about, for you to have under your belt as a basis for everything going forward. Things are going to change. The sooner you get used to it, the easier life is going to be. And that includes mathematics. Okay? This is calculus saying, hey, right here at this spot, right? We zoom way in. It's almost flat, just about. But right here at this spot, right? It is increasing quite a bit. That's actually fairly inaccurate. There we go. It's a little bit better. Okay. Right? We were going up here, and right here, right this spot. Now it was going down. for a little bit. Okay? Take any look at stock markets or what have you, and they have their ups and they have their downs, right? Constantly changing and changing. But there can be an overall trend, right? Overall, we would say big picture, zoom back out, it's going from left to right, right? It is going from smaller to larger. It is, in general, increasing. But there's that part where it was decreasing, right? So we have that change there. The slope is not constant. And calculus is going to look at the large picture in smaller and smaller pieces, zooming in further and further in, right? Until you get infinitesimally close, the tiniest of bits, and what's the change here, and what's the change there, and then itty bitty bits, right? As you go along. Another realm that this is extremely useful, right, would be in physics. And draw a straight arrow here, right? We can have a vector representing some velocity, right? And if this is a velocity, well, that's a change in the position over a change in time, right? All those deltas, right? That means change in. Bonus topic: learn the Greek alphabet. Okay, it'll really help. Triangle, capital delta means change in most mathematics and physics settings, right? So physics, one of, in my opinion, the top reasons for using and learning and developing math, historically speaking. Economics and physics. That's the two reasons we do have math. Right? Change all the time. Physics is, in a very broad definition, about how things move and change. How does matter and energy move and change in the universe? Because it's not static. Stuff happens. One was one way, and now it's another. What went on? Something changed. Mathematics is going to describe that change in a very specific, measured approach. Once again, back to economics, interest rates, right? Interest is a change. You owe this much in your student loan. Oh, well, next year you now owe this much because interest, right? Einstein himself said compound interest is the most powerful force in the universe. That's why, because things change. That interest is how your loan is changing, how your debt is growing or shrinking, maybe, if you're lucky. You're paying it off well. All right. One last point here on change. Let me actually go back to the beginning here. Zoom back out. There's something different going on. There is a divide here between these two sides. Okay? This side is a difference type of change, whereas this side is a ratio type of change. Okay? We've, on the right side, over there, right? On the right side, we're dealing with adding and subtracting, right? I added 2, added 1. How much am I adding or subtracting here? And on the left side, we have the ratio realm. How much did I multiply? Multiply or divide. We can, of course, always do the opposite. Remember, inverse from episode 3, right? So that are two different types of changes, and I want you to recognize the difference between difference and ratio. And ratio is probably going to be the strongest. Difference is a little bit more base level, right? It is more common in Algebra 1 and pre-algebra, and elementary math deals with a lot of addition, subtraction. As you get higher and higher, more complex ideas, more advanced mathematics, more and more things deal with the ratio. We are more and more concerned with how things multiply. Mostly, I would say, because of this reality right here. 1, the building towards calculus, and 2, the application of most math in the science or economic fields. We usually multiply things. Very rarely do you have a physics equation with the velocity and the accelerations and the gravity forces and all that, and you add two unlike quantities together. Okay? You can only add like terms, right? You may have heard that. For that very reason, you got to start thinking about ratio as a type of change, right? How can I multiply this to get my end result, right? Your default mental state, what I want you to work on is to create the ratio habit. I do not want to see plus 4. When I say go from 4 to 8, your instinct, try to get to this point. Your instinct should be, multiply by 2. That should be your first go-to. Right? And once you're there, now you're thinking in terms of ratio, you're thinking in terms of multiplicative change, and that will put you in a much better position to understand more math. And that was the goal of this whole series. What are the basic ideas I need to go forward and learn things easier? I think that about covers it, right? 6 pieces. What were they? We started with quantity, and then we had microphone's in the way, right? Quantity, relationship, inverse, variable, shape, and change. That's all 6 pieces. With those 6 elements, you are now ready to go forth into the mathematics world and learn at your own pace. Digest the information out there. There's so much great stuff, and math is doing so many cool things, both past, discovered, known, and there's also tons of new stuff. Things we haven't figured out yet. Problems left unsolved. Dimensions of math left unexplored. That's your opportunity. Go out and do something with it. Find something awesome. Make something amazing. That's what I'm hoping for. But that's beyond the scope of this video. So I'm going to wrap it up here. More from the channel to come, so do the YouTube thing. And I'll see you later. So long, farewell, enjoy the rest of your day.